pulled it back through the center tap. I'm going to clip the center tap, and that mark will show the halfway point between the two sides. And we arrive at the other side. I don't know what was touching ground, but it was grounding out, so it had to go. So I'll replace it. I want to talk about where I am here. This is going to get a little deep. I've got about 190 reasons why I want to try and get this one working, if you know what I mean. And the thing is this happens to be, as luck would have it, the outermost winding of the coil. And what I have here in my hand right here is the original wire that I pulled off of that winding. And it is actually two wires in one. So there were actually two wires ran tandem like that around the length, went all the way here in this ridge. It started down, wrapped all the way around, came back up, and then came up as a completed coil, right? A certain amount of wraps. In the middle of it, there was a center tap. Here is that center tap right here. That center tap tapped on to green over here, right? And that was the center tap for this, okay? What I want to do is I'm going to replace it with coated wire. And the reason why I'm going to replace it with coated wire is simple. Number one, I can't take this transformer apart. I can't take this core out of here. It's in there, it's shellacked. I would destroy the whole transformer doing it, right? So if I were to use this wire that's covered in enamel and try and push it and contort it through this paper, I'd probably end up just destroying the enamel and I'd get shorts anyway. If I use something like this, which is arguably thinner, though I believe can hold the current at solid core, then I don't have to worry about it getting hot and melting the enamel and ultimately failing, because it actually has a actual insulator around it, right? Which is something that they weren't really dealing with when that came out. Incidentally, of course, it's worth noting that if you look at one of the windings on this one, which was two wires, and you lay this over, you could see that it's the exact same thickness. So it's going to be the same number of turns. So what I'm going to do is I'm going to try and wire this. I'm not going to do a center tap. Instead, I'm going to do something more elegant. I'm going to forego the center tap. I'm going to add a potentiometer at the end for hum, and then I may actually do something with the cathode bias for the preamp side and wire it to that. That's actually a trick to further reduce noise, but I'm going to get into that later. Just know there'll be no center tap. What I also may do is run a couple of taps as I approach the end to see which one is actually 6.3 volts or closest to it, right? So I may make it multi-tap because I don't know how this is going to work. And make no mistake, winding this is going to suck. I'm not even going to minimize that. We could see the low voltage AC coil starting to take shape here. I have the first side coming in, back around. I put some electrical tape to hold everything in place, and it's wrapping around here in a clockwise fashion, just like the old one. I'll tell you that it's a pain, but it gets easier as you go along. Less and less cable to work with each time by a couple of inches. Now, a good portion of the way through, everything's still going good. I could see the original lines go all the way up to about here, right? So I know about where to stop, and it doesn't matter again with the multi-taps. It should be okay. You can see I've pulled away a piece of insulation right here. I'm going to drop one of the first taps here. I'm going to do a couple wraps. I'm going to drop another tap again. Put a second tap right here. I believe we're coming to the end. I've got two taps, one far short of the original, one just short of the original, and I'll probably roll one past the original. That way I'll find something that falls into place at 6.3 volts, which was my intent. Each tap has a piece of insulating tape going over the solder, just so it doesn't bite into anything. So in the end, I'm left with 3 taps over here, and here's the other side. So this will set the voltage for the 6.3 volts. I don't know which one's which. Obviously, that'll be found out during testing. I've also added some tape here is the end point to set this off. We're gonna hook this up to the isolation transformer in the variac. I need to isolate every other connection before I do this for safety purposes and clear off the entire bench. That's the only way something like this can be done. I've got the variac hooked up. I have all the other cables insulated. We're just looking at the tube heaters. I'm connected to one of the 3 wires. I don't know which, and it doesn't matter. Right now I'm just seeing functionality, basic functionality. I'm going to dial up the variac. We're going to go with half voltage, so 60 volts AC on the input. I'm slowly going to bring it up. We are on isolation, so we're at about 40. 50. So we're at 60 volts. Looking at a 2.7. Right? So this is half voltage. And I'm assuming 60 volts. The variac could be off. Let's look at a couple other leads. This is 2.68. Right? I'll disconnect. This is not exactly high voltage here. And look at that. 3.6 on the other one. And 3.1. That's a nice spread. Mind you, this is no load. Right? Let me get to... This is 5.3. 7.2. And wow, 6.3 on the nose. We know the 6.3 one's probably going to be no good because it's probably going to be a little bit lower. But then I should probably go and see what the actual voltage is coming in, right? So let me do that. That is a loud transformer, probably because it's not under any load. But it's working. I have my filament voltage. Yeah, measurements show the 7.17 volts is at exactly 116 volts AC, but that's no load application. So it could be a little higher voltage with a lot more load on it. We're gonna find out when we hook everything up, but I think I got it close enough. Reached the cleaning and testing portion of this event. I don't even know if it's gonna be any good. We're gonna hope that if I clean it, it will work. It cleaned up really nicely. Been a good long time since this tube has seen any electricity. Looking for 5,000 on this one. It is not gassy. About 5,100. Yeah, pretty much on the money. We're gonna do a life test on this as well. We got it set for 2,000. Dropping the filament voltage. Still good on the life test. This is a good tube. Second one's cleaned up. We'll see how this one does. No short lights. That's a good sign. That one looks very strong. It's about 5,800. They're probably not going to be evenly matched. Either way, let's do a gas test. It's not gassy. Now we'll do a life test. Yeah, it's good on the life test. Probably not a wonderful match to the other one, but the tube is good. Next are going to be 12AX7s. I'm going to test them all at once. I realize there's one extra. One is the extra one I found stuffed inside the amp, laying there, and the other one is the one that was installed, this electro harmonics. We're just going to test them all. I don't know why they call it 12AX7EH. On both sides of this 12AX7 reading just over 1,500. I don't usually see them reading that high. I don't know what's going on with this electro harmonics tube, but both sides just over 1,500 and it's equally balanced. I'm going to leave the settings just like that. I'm going to pop in another one. Here are all the Silvertones, the originals. And we'll test this one out now. And we see this one's reading 1,300. This sounds a lot more correct for 1,250 reading 1,300. That sounds about right. Let's look at the other side of this one. Oh, this side's got a dirty connector. Let me clean these. Try it again. And we're seeing 1150. So, yeah, it's about balanced. I didn't bore you with each one, but I'll tell you that all the 12AX7s tested good. And I'm moving on to these 6 FQ7s right now. letting the first of two 6 FQ7s warm up, no shorts. Seeing 2800 shows 2600 on the chart. That is good enough for me. Other side shows 2600 or 2650 of 2600. Other side is good. This tube's good. Would you know it, right on the last tube, both sides are evenly weak. This one is showing 1400 of 26, and that was the last tube as before. It should be sitting right up around here at 26. And this is side B, 7608. And here's side A, 2103. So yeah, this one didn't make it. All the other tubes test good. This one tests weak. Incidentally, this is the pass-fail test, and it has failed. Replace. So yeah, this tube did not make it. That concludes the tube testing of this project. It's time to clean these nasty things right here. This will be fun. This one I had pre-cleaned really quickly because I was using it as a test piece. This is what the knob looks like when it's reasonably clean. But this is what it looks like when it reasonably is not. There we go, they're all clean. They'll be stored till the end of the project. Since this cap is staying as a showpiece and not being used, I just decided to polish it up and leave it in place. So there it is, all shined up, and that's it for that. I'm going to start hitting the pots with some deoxit, spraying it in the ones that are aligned right for this task. Some of them are not, and they'll be hitting the second round when it's flipped on its side. That's crusty. We'll work it out. We'll see how it goes. We'll be hooking the meter up to all these anyway. Having finished the pots, I have sprayed out all of the tube sockets. And now I'll be using my tube socket brush to clean out each and every socket individually. Kind of goes something like this. Over and over again for however long. After scrubbing it with the brush, I blew it out with the compressed air. The amp's a mess, but the tube sockets are nice and clean. As I had suspected, the covers for the clasps are rusted on. So what I did was I actually tapped this out from the other side. I'll show where to get this off safely without damaging it. Now that it's removed, I could separate it, clean this, paint this, do whatever I want to this. But getting it off was required in order to be able to address this. You can see it's coming out rather nicely, you know, as compared to the before. But I do need to make this trap go away to finish this project. And I just get under here, I'm tapping this with a screwdriver, just getting it loose enough. Eventually I could hand turn it and get it out that way. It's unconventional, but it does do the job. We're past the halfway point. Things are looking really nice now. Proceed onward. So I finished the stain removal work from this box, including the front, the sides, the back, and what have you. I think it came out pretty nice compared to what it looked like before. In case you forgot what it looked like before. That's what it looked like before. So, yeah, major improvement indeed. I'm very happy with the way that turned out. And take care of the handle as a separate matter. So I set up an impromptu test here of the Reverb Tank in an attempt to make sure everything's working. Not that there's much to break, but I've set it up here in the O-scope. It's not an audio test, it's a visual test. So I have everything perfectly still, and now I'm gonna hit the spring, right, with my finger. We can see there was a definite response there. So, I mean, things are working. I can run that test in the other direction too, make sure everything's okay. And in the other direction, again, we see that the components are working fine. I'm gonna say it's probably okay. And we're gonna slap it back in and hope that it works in circuit. My next order of business is gonna be to take care of this dumpster fire right here. I don't know what happened. I don't know if something got really hot, and you can see one cable clearly melted the insulation straight off the cable. These are all disconnected. There is also a wire right here, and this is actually correct. It goes in behind the chassis and comes out here. It's that red wire. Wow, that's terrible. But that's not how he designed it. I'm gonna have to fish that out first. That's gonna be my first run. I'm gonna fish that out. I'm gonna run a new red wire from here all the way to here. I'm just going to pull some new wire straight through. There we go, the cable run is complete. Just needs to be soldered back in. I've cleaned up all of the solder points, removed all the old wire connections. I've replaced this black cable. I know that it happens to be black in the original, and I'm ready to add this one now. This will be the next one. And there we go, that's all there is to it. Red cable is now also reconnected on this side. Got the next cable reconnected. Starting to look good. All the connections are now back in place. I'm just going to research how the grounds are handled for this particular set of switches, that's all. We're going to do mechanical inspection of each pot. I have it connected to the first one. The values of the pots themselves are not going to be right because they're in circuit, they're connected to other components, but what I'm going for is just making sure that the inner workings work. So I'm just going to slowly increase it. You get to a certain point, it's going to plateau and then bump back down. That's fine. I'm going to move on to the next. Connected to the second one. There we go to the end. On to the next. On the third one now. Very good. The fourth. Another one with the bounce. Gets to the top threshold. See, it comes down a bit. That one's good. The fifth. It's good. Sixth. It's good. Seventh. One's got a bounce to it. Also, the seventh has a switch mechanism. Okay, it's starting to work. Contacts are dirty. Switch is good. Eighth. Eighth is good. Ninth. Ninth is good. All the controls are good. Ended up with a nice hammer tone finish on this. I sprayed it with the black epoxy after I'd sanded it, and then I sprayed it with the silver. Came out really good, nice texture. So that's about dry. That'll go back in the amp along with the reverb tank. And there we go. I just laid it on there for contrast purposes. That looks just fine. Never thought I would be closing up something in an amplifier using duct tape, but here we are. This is the reverb tank ready to go. My capacitors have arrived, so we're going to start swapping them out now. These ones laid across here, plus I got some for the electrolytic can that I'm going to do some modifications to fit that in. I'm just going to get started on this now. Okay, all these swap outs are done. We're moving on to the next phase. The next phase is going to be this electrolytic cap down here, 3-part. What I have to do first is come around topside here for a moment and identify what these are. So we got our square, our triangle, and our slash to determine the values. A square is 20, triangle's 10, and slash is 5. It's not easy to see, but I've identified that up here, these orange ones are square. Moving this out of the way, this red connection here is triangle, and by deduction, this one over here is the slash. I'm thinking that I may be able to connect this standoff right here to this ground lug, and this would provide me 4 connections, the center one being ground, right? So I would have ground plus 4 connections. I only need 3, so this would be good. And all of those connections can be cut off and moved over and transposed right onto this with the new capacitors. So let's stage this and see what we got. So everything is secured down. I've got it screwed in. This center one is tied to ground, so that is all ready to go. What I need to do is now start cutting these back to their new locations. I just need to establish which one is going to be what, tying them off, and then bringing in the capacitors. So I'm just going to move one at a time. See, the first one has been migrated, not completely soldered in yet. I don't want to solder it till the next set of connections goes in, but 5 is completely stripped, including the resistor that carries 5 to triangle, which is 10. So we could see 5 in place, everything cut across, and then that resistor coming across right here. And this is where the capacitor for 10 microfarads will sit. And then I will obviously be cutting across the red connection here for 10. That will connect there too. And then the resistor from that one will bounce over ground here to the third connection. That will be 20. Now I have the 5 and 10 in place. We can see I've replaced the resistor. There just wasn't enough length on the old resistor to jump all the way across, so not a problem at all. Again, now 2 grounds are running to this center post here. I still have not soldered them, awaiting the third capacitor before I do so. So now I'm going to cut the third one out, and I'm going to bring it over to here now, to this post. This wire was the only one I actually had to extend to meet the new location. So I've just added on this old piece of red onto here. And there we go. With that, everything is moved over to the new capacitors. This capacitor is now completely empty, serves no purpose except for show. This portion of the project is now done. And with that, all the capacitor replacements up here are done. Let's check out this light bulb right quick. Filament looks okay. We'll put the bulb back in. That'll be checked later to see if it works. No big deal. I'm going to modify these before anything else. I don't want to have to keep ripping out the cables to do testing on these because these have already been worked. Because the transformers have already been worked. So I'm going to Dremel this out so the cables can loom through here even when they're installed. Here we go. I got them cut out now, and I got them filed down nice and smooth and not sharp anymore. The reinstallation for the transformer now begins. We can see that the cables are coming through into the chassis. Also includes where the new fuse will go. We can see half the shell is still off. I'm leaving it off so I could do some testing of this to make sure that it's adequate. So we're going to put that on after that's done. Now I've got all the leads installed on this side except for the power going to the fuse. I've just installed now the new fuse holder, and that is in without the cap. And I'm going to connect those wires and then put in the new fuse. Cables are now connected. Fuse is installed. So this is what I'm left with up top. I'm still going to connect these green wires like usual, no change there. One side, this one specifically, will be connected to the heater just as before. What I'm going to do with the other side is I'm going to tape off 2 and connect 1 to the heater. And I'm going to basically go through all of them and ultimately find out which one is going to be the most effective for this. So it's basically be a temporary run, not a permanent fixture. So I can see that with the full complement of tubes, which one is going to bring me closest to 6.3 volts. I've added 2 pigtails to the heater over here, so I could bring these top side to do the work on that heater winding. Ultimately, this yellow wire will have to be cut, and it will have to run to a potentiometer that will have to go into the back side here. There is no center tap on this new heater winding, right? I've replaced that with something much more elegant, and that's going to be installed as part of the next part of this wiring.